What is delegate? Delegate refers to a method. We can declare delegate same as method using delegate keyword. Then we can create delegate instance using delegate, which refers to a method. Delegate and method both should have same signature. The delegate instance can be used for invoking the method referred by delegate. So delegate provides the way to encapsulate the method. In C or C++ language, we have callback mechanism where function pointers are used for pointing functions. But here in C sharp, delegate is used for referring static and object methods. Delegate have information of number of parameters, return type, whereas function pointer have information of function address only. So we can say delegates provide type safety, secure and appropriate for object oriented way. Delegates are useful where your callback mechanism and event handling is required. Declaration syntax. This is the declaration syntax of delegate: modifier, delegate, return type, delegate name, and parameters. The delegate signature should match with the method signature which we want to refer by delegate. Modifier, it can be private, protected, public, new, or internal. Delegates are derived using system.delegate class. It's another class type, so it can be defined at places same as applicable for class. By default, they are sealed, so cannot be derived further. Return type, the return type of delegate, delegate name, the name of the delegate, and parameters. Delegate example. Let's see some delegate examples. The first one is delegate add number. It has two parameters of type int and return type is int. So it will refer to method which is having two parameters of type int and return type is int. The second delegate is display. It has one parameter of type string and return type is void. So it will refer to method which is having one parameter of type string and return type is void. And the third delegate is getName. It doesn't have any parameter and return type is string. So it will refer to method which is not having any parameter and return type is string. Delegate referring to methods example. So here we have delegate, number delegate. It has two parameters of type int and return type is int. So it can refer to method which is having two parameter of type int and return type is integer. Okay, let's see some methods which it can refer. So here we have method add, subtract, multiply, divide, modulus. All of them have two parameters of type int and the return type is int. So delegate number delegate can refer to any of the method add, subtract, multiply, divide, modulus. Let's see another example. Here we have delegate, display delegate. It has one parameter of type string and return type is void. So it can refer to a method which has one parameter of type string and return type is void. Okay, let's see some methods which it can refer. Here we have two methods. First one is print str. It has one parameter of type string and return type is void. And here is another method, show it. It has one parameter of type string and return type is void. So we can see the delegate signature is matching with these methods signature. So delegate can refer to any of the method available here. Delegate instance creation and invocation. So here we have delegate, operation delegate. It has two parameters of type int and return type is int. So it can refer to a method which has two parameters of type int and return type will be int. Okay, we'll see how delegate instance is created and invoked. So here we have delegate instance OPR VAR, and here we are passing the method add. So add should have same signature as delegate operation delegate. So add will have two parameters of type int and return type will be int. So here we have created delegate object OPRVAR which has encapsulated the method add. Okay, we'll see how it is invoked. So here we are using delegate instance OPRVAR for invoking the method, and we are passing two parameters and the values are 20 and 10. So in turn it will invoke the encapsulated method add, and the returned value will be assigned to variable temp val. Suppose delegate has return value void, then it can refer to method of same signature. So the method it will refer will also have return type void. In that case, it can be invoked in this way. So we can just use the instance variable OPR VAR and we can pass the parameter values. So in turn, it will invoke the method which is encapsulated in delegate object. So you can see here we have declaration of delegate. We have delegate operation delegate. It has one parameter of type string and return type is string. And here we have class computer system, and it has method start application, stop application, install software, uninstall software, and the method operation. Okay, right now we are interested in only first four operation. So we can see all four have same signature as delegate, has one parameter of type string and return type is string. So the delegate can refer to these methods: start application, stop application, install software, uninstall software. Okay, let's see the main. So here we are creating the computer system object COMSYS obj, and then here we are creating delegate instance OPR delegate, and the method we are encapsulating is install software, and then we are using delegate instance OPR delegate to invoke the method, and we are passing the parameter value my application. So it will invoke the encapsulated method install software. So it will come here and it will display this, and here it is just returning the value success. So it will display success, and then it is encapsulating the method start application, and here it is using delegate instance OPR delegate to invoke the method, which will invoke the method start application now. So it will come here and it will display this statement inside computer system start application, and then it will return the value success, and the value success will be displayed here. And then we are encapsulating the method stop application, and here we are using delegate instance OPR delegate and passing the parameter my application. So this time it will invoke the method stop application. So it will come here, it will display this statement and it will return the value success, which will be displayed here. Result is equal to success. And then the last statement is we are encapsulating uninstall software, and then we are using delegate instance OPR delegate to invoke the method. So this time it will invoke the method uninstall software. So it will come here, it will display this statement, and then it will return the value success, which will be displayed here. Okay, we will run this program and we will see the output. So we can see first time when delegate instance OPR delegate is used for invoking the method, it invokes the method install software, and it goes to method install software, it displays this. You can see inside computer system install software, and result is success, which is displayed by this statement. And the next one is, you can see inside computer system start application, because this time start application method is invoked. So inside the method the statement displays this, and result is success. And the third one is inside computer system stop application. So we can see here this time stop application is encapsulated. So this invokes the method stop application, and this is displayed, and then result is success. And the last one is uninstall software. So we can see it goes inside uninstall software and it displays success. Passing delegate as parameter in method. We can pass the delegate as parameter to a method. Let's see one example. Here we have called the method show string. It has first parameter string hello, and the second parameter is delegate display string. And here is the method. The type of first parameter is string and the type of second parameter is delegate display delegate. So here we are using the display delegate reference dispstr for invoking the method, and here we are passing the parameter string value. So in turn it will invoke the method which is encapsulated in the delegate object display string. Okay, we will see how this is implemented in C# source. So here we have same example. We have delegate operation delegate with one parameter of type string and return type is string, and we have class computer system. It has methods start application, stop application, install software, uninstall software. These four methods have same signature as delegate. So delegate can refer to these methods. And we have another method operation with two parameter. First parameter is of type string, second parameter is of type operation delegate, and return type is void. Okay, we'll come to this method. So let's see the main. So here uh, we are creating delegate instance OPR delegate, and we are encapsulating the method install software, and then we are using delegate OPR delegate we are passing the string my application. So it is going to invoke install software. Then we are encapsulating start application, invoking the method, then stop application, invoking the method, uninstall software, and then the method uninstall software is invoked using delegate instance OPR delegate. Now we will come to these statements to understand passing delegate in method. So here we are encapsulating the method start application. Okay. And now we are calling the method operation. First parameter is string my application and second parameter is the delegate instance OPR delegate. So we are passing the delegate instance. So it will come here and we can see second parameter is of type operation delegate. So the delegate instance which is passed here is received here, and then we are using OPR delegate for invoking the method, and here OPR delegate has encapsulated the method start application. So it will invoke the method start application. So it will come here, it will display this and it will return success which will be displayed here. Okay, we will run this program and we will see the output. So we can see here we have used OPR delegate and we are passing name which is my application. So it will come here start application because OPR delegate has encapsulated the method start application. So it will come here and it will display this. So we can see inside computer system start application. Result is success which will be displayed by this statement. So inside start application it will display this statement and inside operation it will display this statement. So the delegate will be passed in this way in method. Multicast delegates. A delegate can have multiple methods and they can be invoked using it. That means a delegate can encapsulate multiple methods and all the methods can be invoked using the delegate object. But all the methods should have return type void. Okay, let's see one example of multicast delegate. Here we have delegate operation multicast delegate. It has two parameters of type int and return type is void. That means it can refer to a method which has two parameters of type int and return type is void. Okay, here are the methods which can be encapsulated in the delegate operation multicast delegate. So we have method add, subtract, multiply, divide, modulus. All of them have two parameters of type int and return type is void. Adding methods using plus equal. So we can add methods in delegate using plus equal. So we can see here we have delegate OPR multicast delegate. So we have delegate object OPR multicast delegate and here is the method add encapsulated in delegate object OPR multicast delegate. And then we are encapsulating another method subtract in delegate object OPR multicast delegate. Then we are adding the method multiply, and then we are adding the method divide, and at the end we are adding the method modulus. So all the methods add, subtract, multiply, divide, modulus is encapsulated in delegate object OPR multicast delegate. So now we will see how to remove methods from delegate object. So we can remove the methods using minus equal. So here we are removing the method divide from delegate object OPR multicast delegate. So now we have methods add, subtract, multiply and modulus only encapsulated in OPR multicast delegate object, because we have removed the method divide from delegate object OPR multicast delegate. Multicast delegates invocation. So we can use the delegate instance OPR multicast delegate, where we can pass the parameter values. Here we are passing the parameter value 20 and 10. So it will invoke all the methods which are encapsulated in delegate object OPR multicast delegate. So the methods encapsulated are add, subtract, multiply, divide and modulus. So it will invoke all the methods with parameter value 20 and 10, which is passed here. So we can use multicast delegates in event mechanism, which we will see later. So here we have delegate operation multicast delegate. It does not have any parameters and return type is void. Remember, multicast delegate can refer to methods which have return type void. So that's why we have delegate which has return type void. Okay, here we have class data center and it has member variable server, printer, cooling system and delegate operation multicast delegate reference OPR. And this is the constructor of data center. So here we are creating object of server and assigning it to member variable server. Then we are creating object of printer and assigning it to member variable printer. Then we are creating cooling system object and assigning it to variable cooling system. And here we have method start for starting the data center, and we have method stop for stopping the data center. We will come to these methods later. And here we have class server. It has method start and shut down. So inside this, it is just displaying this statement. So intention is to start the server, but here this is just an example. So we are just writing inside server start and inside server stop or shutdown. And this is the class printer. This also has method start and stop. And here also we are just displaying the statement start and stop. And this one is the cooling system class. And this also has method start and stop, which is just displaying the statement. So we can see we have methods start and stop, and these methods does not have any parameter and return type is void. So delegate can refer to these methods. Okay, let's see the main. Here we have created data center object and assigned to variable dcobj, and then we are calling the method start of data center object. So it will come here, and here we can see we are encapsulating the method start in multicast operation delegate instance variable OPR, and then we are adding the method start of printer. First one was start of server object. Second one is start of printer object, and we are using plus equal for adding the method. Then we are adding the method start of cooling system object, and again we have used plus equal for adding the method, and then we are using delegate instance OPR for invoking the methods. So right now server start, printer start, and cooling system start methods are encapsulated in delegate instance OPR. So it will invoke these methods. So it will come here, it will execute this, it will execute this, and then cooling system start. Okay, and this is just an example. So after that we are removing the methods from delegate instance OPR. So first we are removing server start method. So we have used minus equal for removing the method. Then we have removed the method printer start, then cooling system start. So right now delegate instance OPR is not encapsulating any method. This is just an example because uh, I want to show uh, encapsulating of other methods of server. So we will see in the main. Now we are calling the method stop for stopping the data center. So it will come here stop, and here we are encapsulating the method shutdown of server. So delegate instance OPR has encapsulated the server method shutdown, and then we are adding the method stop of printer, and then cooling system stop is added. We have used again plus equal, and then we have used delegate instance OPR for invoking the methods. So all the methods which are encapsulated will be invoked. So it will invoke server shutdown, printer stop, and cooling system stop. So it will come here, it will execute this, then the stop of printer will be executed and stop of cooling system will be executed. And then again we are removing the methods from delegate instance OPR. So first server shutdown is removed, then printer stop, then cooling system stop. Okay, we will run this program and we will see the output. So you can see we are able to encapsulate multiple methods, and when we invoke the delegate instance, it invokes all the methods which are encapsulated. So we can see here starting data center, then it goes to start, and it has come here. And when, so these methods are encapsulated, so when it invokes, in turn it invokes all these three methods: server start, printer start, and cooling system start. And similarly, here the stop is called, and this time the methods shutdown of server, stop of printer, and stop of cooling system is encapsulated. So here we have used delegate instance OPR for invoking the method. So it invokes all these three methods. So here server stop, printer stop, cooling system stop. So you can see here in server shutdown, it displays inside server stop, and then printer stop, and then cooling system stop. So we can see multicast delegate provides the facility to encapsulate multiple methods, and all of them can be invoked using multicast delegate. Events. Events are messages raised to notify the object on a particular action. There may be a lot of scenarios where we would like to notify different objects to take appropriate steps. For example, system management product will notify the system health to different objects for taking appropriate steps. The class raises the event is called event sender, and the class receives the event is called event receiver. Event receiver class will have event handler method which will handle the event. Declaration syntax. This is the declaration syntax of event. Event, delegate type, event name. Event is the keyword, delegate type is a delegate type name, and event name is the name of the event. There may be scenario where event has to be handled by multiple methods, so the events can be used as multicast delegate and can have multiple event handlers to handle the event. Passing data with event. We can pass data with event as we may require some information to be passed to handle the event. For this, we have to define a class derived from class system.eventArgs. Then create the instance with initialized data and pass it with event in event sender class. Event mechanism. Okay, let's see all the steps required for implementing event mechanism. Step 1, declare the delegate. So first we have to declare the delegate. Step 2, identify the event sender and event receiver class. So we have to identify, or we have to come up with event sender and event receiver classes. Step 3, define the event in event sender class. Step 4, define the method to handle the event in event receiver class. And we can have multiple methods to handle the event. Step 5, create the object of event sender class. Step 6, subscribe, unsubscribe from the event. So event can be used as multicast delegate. Step 7, define the class for sending the data. Step 8, raise the event. And here while raising the event, we can pass the data. Okay, we'll see how this is implemented in C# source. So here is the source code. Okay, let's go through all steps. So step 1 is declare the delegate. So here we have delegate, event delegate. It has two parameters. First parameter type is object and second parameter type is event args, and return type is void. So it can refer to method which has two parameters, and first parameter type should be object, second parameter type should be event args and return type should be wired. Okay. The second step is identify the event sender and event receiver class. So we have class event sender here and we have class event receiver here. Step 3 is define the event in event sender class. So here we have defined the event in event sender class. So we have used the keyword event for defining the event. So event is event where. Okay, let's go to the step 4. Define the method to handle the event in event receiver class. So here we have methods event handler 1 and event handler 2. You can see it, both of them have two parameters. First parameter type is object, second parameter type is event args and return type is wired. Okay, now here is the step 5. Create the object of event sender class. So we have created the object of event sender class. Obviously we have to create the event receiver object also. And step 6 is subscribe unsubscribe from the event. So here we have subscribe the method event handler 1 of event receiver obj. And step 7 is define the class for sending the data. So here we have class event sender args derived from event args, and we have member variable data, and in the constructor we are initializing the member variable data with parameter value. And the step 8 raise the event. So here we are raising the event. We are using the event where, and here we are passing the data. We are creating the object of event sender args and we are passing the value 5. So data is initialized with value 5. Okay, let's understand the complete mechanism. So we have delegate here, then we have class event sender args here for data, and we have event sender class. It has event, and here it has method raise event, and inside this we are using event for raising the event. And this is the event sender class. It has methods event handler 1 and event handler 2 for handling the event. Let's see the main. So here we have created event sender object and event receiver object. Then we are subscribing event handler 1 method of event receiver object to the event where, then we are calling the method raise event of event sender obj. So it will go to raise event of event sender obj. So here is the event sender class and raise event method. So here we are raising the event. So it will raise the event which will be handled by the method event handler 1, because right now we have subscribed event handler 1 method of event receiver obj. So it will come here, and here we are just displaying this statement, but in actual the event will be handled here. Okay, and here we are adding the method event handler 2, and then calling the method raise event. So now we have subscribed two methods, event handler 1 and event handler 2. So when we are calling the method raise event, it comes here, and when the event is raised, it is handled by methods event handler 1 and event handler 2. Why? Because now two methods are subscribed by event handler 1 and event handler 2. And here we are removing the method, unsubscribing the method event handler 2. Method of event receiver obj is unsubscribed. And now when we call the method raise event, it comes here, and here it raises the event, and this time only one method is subscribed, which is event handler 1. So event is handled only in the method event handler 1. Okay, we will run this program and we will see the output. So we can see first time only one method is subscribed, event handler 1. So when we raise the event, it comes here, and when event is raised, it is handled in this. So it displays inside event handler 1. Next time another method is subscribed, event handler 2. So when we call the method raise event, it comes here, and when the event is raised, it is handled by methods event handler 1 and event handler 2. So it is displaying inside event handler 1, inside event handler 2. And third time we have unsubscribed the method event handler 2. So when we call the method raise event, it raises the event here, and this time the event is handled by event handler 1 only. So we can say see inside event handler 1 is displayed.